thank you for the opportunity to present here what has been, or at least our investigation that we are carrying out with the University of Valencia and the company Aguas Municipalizadas de Alicante. Aguas Municipalizadas de Alicante is the company that manages all the water cycle in the city of Alicante. That is a city in the southeast of Spain, in the Mediterranean coast of Spain, where I actually work. The project is about the effects of climate change in the main hydrometeorological variables, the temperature and the precipitation, in a local scale. That's important. We need the resolution of a local scale for our calculations. First, I have to say that I'm not an expert on climate science and climate change. I'm not a climate scientific, but I suffer directly the consequences of high intensity events, of big rains, since I am the chief of the urban drainage department in the company Aguas de Alicante. So I manage the urban drainage of the city. Well, I wanted to start my presentation by showing you how rains in the city of Alicante. For doing that, we have investigate the last 83 years of precipitation data. And we have classified them in moderate, heavy, very heavy, or torrential based on its intensity. As you can see in the graph, as you can see in the graph, there is a trend of decrease in the moderate intensities, but there is a trend of increase in the heavy, very heavy, and torrential. That starts giving us some clues about how will the future be? How will the future be in the city in a near term? Here you can see some images of the worst episodes of precipitation in the city. The worst of them was in 1997. Where we accumulate 300 millimeters in a few hours. 300 millimeters is about all the global amount of precipitation in 1 year. So it was a very important event. And as you can see, all the events happen in the last half of the historical series, in the last 40 years. Well, one way to define how rains in a particular location, in this case in the city of Alicante, is the use of what we call IDF curves. The IDF curves represent the mathematical relation between the rainfall intensity, the duration of the precipitation, and the return period associated. With these curves, we can define the design hydrograms, the synthetic rainfalls that we use for design the urban drainage infrastructure. But these IDF curves have a main problem, that they are based in historical data. If we introduce now a new variable, a climate change variable, we don't know if we are designing now infrastructures that won't be efficient in a near future. No, that's the problem. So that's why it's important for us to know how precipitation, how temperature will evolve in the future, and how can we project these variables to the future. For doing that, to project these variables in the future, we have collaborated with a company, a climate services company, that is Predictia. They are a spin-off of the University of Cantabria. that has developed a tool, a web tool, a Python-based web tool that is Climadjust, that allows us to make these projections, okay? So we have done, with their help, 2 experiments, one for CEMIP 6 with 5 simulations, other one for EURO-CORDEX with 51 simulations, and we have done projections to year 2100 in 3 different climate change scenarios. One optimistic with reduction of emissions, one business as usual, and one pessimistic with increase of these emissions. Well, the reference data sets for precipitation have been the observational data from the observatory of Ciudad Jardín, that is an AMAEM observatory of the Spanish Meteorological Agency. And for temperature, we have used the reanalyzed data sets of ERA 5 lands. Well, all the data have been adjusted by bias adjustment capabilities that provide Climadjust. Well, we can see some of the data that we have obtained with Climadjust. We obtain temporal data with the daily resolution. You have here all the variables that we have obtained. But we need, as I have said before, more detail. So we have had to do a temporal disaggregation, a kind of temporal downscaling, to obtain the hourly temporal resolution data, to project the IDF curves, and to obtain a torrentiality coefficient, local and specific to the city of Alicante. Well, that's the methodology. Let's see some results. Well, you can see here the results for the 2 experiments, CEMIP 6 and EURO-CORDEX, and for the different climate change scenarios. Well, the graphs are easy to understand. You have to see the clear blue line, that is the adjust one. If we quantify, in this case, we are showing the number of days with precipitation above 1 millimeter. Well, if we quantify the diminution of the decrease of this variable, we see that in the optimistic scenario, it is a 10%, a 20% in the business as usual one, and a 30% in the worst one. No, in my opinion, it's a lot of reduction. If we do the same thing with the temperature variable, well, we see something similar, but in increase. In this case, in the optimistic scenario, we have 0.5 Celsius of increase. In the business as usual, and most probable, I think, scenario, 1.5, and in the worst one, almost 3 Celsius. That is, again, a lot. Well, 1.5 is a lot too. Well, if we descend to an hourly data resolution, we can do this projection of the IDF curves. In this case, we are presenting the IDF curves, the intensity duration curves, in different graphs per different return period to be more clear. You can see the line represent the intensity duration curves based in historical data, and the shadows represent the envelope of the maximum and minimum projections that we have obtained. Sorry. As you can see, in all cases, almost in all cases, in all return periods, and for all the duration of the rainfalls, we obtain intensities higher than the ones that we obtain with the traditional methodology. Okay. So, well, this is the This is the most probable scenario, the business as usual one. These are the results for the worst scenario. So as a conclusion, we have obtained, in one hand, less precipitation, an increase on temperatures. That's very important for us because our drought plans must be monitored and must include protocols to deal with different levels of the problem. Traditionally, the water for human consumption, the irrigation, and more important to us, the tourism, because Alicante is a very touristic city. And we need to define the strategies for water resources management. We think that the best way is to make regeneration and water reuse from the wastewater treatment plants. Okay, we generate a new resource with these treatments. On the other hand, we have an increase on rainfall intensities, an increase on torrentiality. So maybe we have to change the paradigm. We have to start the design on different, to start designing with this new hypothesis to make more resilient urban drainage infrastructures. For us, it's essential that the collaboration between the water cycle companies like me and the climate services company or investigators like you, and for sure with the local, regional, or state administration that normally are the owners of the infrastructure of drainage. And for sure, we think it's important that these climate projections can be considered into urban planning tools. Next steps. We have just finished the mathematical modeling for the drainage network of the city of Alicante. We are going to introduce the results of these new boundary conditions that we have obtained. Another variable that is very important for us is the increase of the Mediterranean sea level, because it has a capital influence on the evacuation capacity of the urban drainage network. And we are going to study how the urban drainage, sustainable urban drainage infrastructure or nature-based solution can resolve some of the problems of the cities linked with the climate change. And we're going to study too how the climate risks and their economic consequences will evolve. To finish, I just wanted to show you how is the city of Alicante facing this new problem, these future challenges. And we do with two lines of action. The first one is with the strategic plan, Alicante Agua Circular y Verde, Alicante Circular and Green Water, that is based in three pillars. The first one is the boosting of water reuse. The second one is the protection of the receiving water bodies. And the third one is the prevention of flood and sewer overflows. And for this, we are planning the construction of, an amount of underground tanks or some other urban-based, nature-based solutions. One of the problems of this is for sure the budget of this actuation that is quite big. Nature-based solutions, for example, like the La Marjal Flooding Park. This is a solution that is working since 2015 and with very good results. This park has a capacity of 45,000 cubic meters of storage for run of water. Or, for example, some other project that the city is projecting, for example, the reconstruction of the La Almadraba beach, by including some, retention tanks, some bioretention tanks, some infiltration trenches, solutions to try to control the peak of floods in the city. And well, for my part, is everything. I hope it has been.
Thank you. Some questions?
Thanks a lot, Luis. I wonder if the budget for the adaptation strategy, the strategies that you showed in the end of your talk, come from European projects or Spanish or just from the city?
The budget is just an estimation that we have made in this strategic plan. And now comes the problem. How are we going to find funds for this? We are trying to have funds from the European Union, but where there are many possibilities. Mm-hmm. No. Mm-hmm.
Hi, thank you. You show results for CIMIC 6 models and also for EURO-CORDEX, right?
Mm-hmm.
Do you find any added value of using these regional climate models results? I mean, do you get any differences between the two sets of models?
Mm-hmm. We wanted to compare both initiatives for that reason, because we wanted to determine if they conflude or not. We have the results show that the EURO-CORDEX data are more restrictive than the CIMIC 6 one, but the CIMIC 6 one, for us, studying in our experience, we think that fit better with the what we think that the future will be. Mm-hmm. Yes. Mm-hmm. Yes. Mm-hmm.
Other questions? Maybe I got one. You've quoted the EasyMIP intercomparison project on impacts. Yes. Do you know what will be the next priorities for this intercomparison project? What are the main directions? For instance, do you think that we should progress also in the bias adjustment techniques or the statistical downscaling techniques that are used, or do you think that another priority could be to use constrained projection rather than raw model outputs? We know, for instance, from IR6 that we are now able to constrain at least temperature changes, even at the regional scale, based on the available record. Is it something that EasyMIP is planning to do as well?
Mm-hmm. Well, that's a good question, and I'm afraid I'm not the person that can respond you. Maybe because I'm not an specialist of this issue. Maybe we could talk with our partners in this case, Predictia, to answer better your question. I'm afraid I cannot do it. Thank you.
Okay, I guess it's time for lunch. Thanks everyone, and thanks to the speakers again.